All right, here we go. Circuit number 3. This is loads of fun all the way throughout. So here we go. All right, take a look-see. Starting off, I imagine my electron drifting along. It can go this way or this whole route over here, right? So this is in parallel with this big old mess over here. And it goes through this resistor, has to go through that resistor, has to go through one of these two resistors. So these two are in parallel because it's either one or the other one, right? So these two are parallel, right? And then this parallel is in series with these two. And then this whole thing over here is in parallel with this one here, which now every electron that comes through either one of these paths has got to go through this one over here. So that's going to be in series with that. Okay. So I'm going to, you should pause it if you're like, okay, now I got it, I'm going to try it. If not, we'll move forward. Okay, so 1 over RT equals 1 over 10 plus 1 over 20. Doing that calculation really quickly, I do 1 divided by 10 plus 1 divided by 20, and I flip the whole thing. 1 divided by shift answer, and I get 6.667 ohms. Okay, so if that's 6.67 ohms, then these two together count as that. But if I then look over here and go, wait a second, everything that goes this way has to go through this parallel system, right? So everything has to go through the 30 and the 40. So the resistance total for that whole right-hand side of the circuit is going to be 40 plus 30 plus going through the parallel system, which we're going to treat as one thing, 76.67 ohms. Okay, so now I look at it and go, okay, so now my theoretical particle could have gone this way or this way, correct? So therefore, my resistance total now is going to become 1 over RT, right? Because these are parallel. It's a parallel path. I can go this way or this way. Electron doesn't do both, right? So 1 over RT equals 1 over 76.667 plus 1 over 120 ohms, right? Those are my two choices. So I'm going to do 1, delete. Okay, so 1 divided by that plus 1 divided by 120, 1 divided by the answer of that, and I get my resistance for that whole left-hand side of the whole, everything but that 5 ohm resistor is going to be equal to 46.8 ohms. Having that, I recognize, wait a second, everything that goes through this big old mess has to go through that resistor, so the resistance total of the whole entire ugly mess of fun is going to be, resistance total is going to be equal to 5 plus 46.8, and so that's going to give me 51.8 ohms. So the total resistance of the whole entire thing is that. So now I'm going to play the game. Are you ready for the game? Let's play the game. How do you play the game? This is how you play the game. You go, all right, my resistance, sorry, I'm going to get ready to do this thing. I'm going to go that my V total equals I total plus R total. So V total is 100. My I total, I don't know, but my resistance total is 51.8. And so now I'm going to divide that out. I get 100 divided by 51.8. Is 1.93 amps. So my total current coming out of the battery is 1.93 amps. And so now I know coming out this way is 1.93 amps. All right. Whew. You've answered one question. 1.93 amps. Now I want to find the total resistance out the current going through each and every one of these things. So I go current in 1, current in 2, or sorry, current in 6, current in 2, current in 3, current in 4, and current in 5. I'm not going to write those answers, but you guys can follow along. All right, so how do we do this? So we're going to now look at this thing and go, all right, well, if that much current's coming out of the battery, then it must all go through this one resistor here. So the voltage drop across there, must be V equals IR, right? V equals IR. And so that's just going to be V equals 1.93 times 5, and I get 9.66 volts. 9.66 volts. Okay, so now I got 9.66 volts there. What's left over for the rest of the trip? Well, I note that from here to here, I must lose the rest of the voltage, right? Whether I go this way or just this quick little route across this one big gnarly resistor, either way I got to lose the same voltage, and that's going to be 90.3 volts. Okay? I simply said if I lose 9.66 of my 100, I only get 90.3 left over for these two routes. Well, it's really simple to figure out this route, isn't it? Going this way, my current has to split. I'm only going to get some of my current there, but it's really easy to calculate what that is. I'm just going to go V, oh, that's really far off of where I guessed it was, V equals IR. So a V, which is the voltage, is I don't know, but my current going through is 1.93. So how much voltage am I going to use up? Going through a 5 ohm resistor. I already did that. Ooh, that was terrible. I already did that. What am I doing now? Hold on. I lost my train of, oh, I'm supposed to do the second one. Hold on. Do the purple zone. My bad. Lost my train of thought. Where's my eraser? Eraser. Oh, it's not going to give me my eraser. That's terrible. That's too bad. Can't get an eraser. Okay. So actually what's going to happen is I'm going to use V equals IR. So the voltage drop I have to use across that resistor is going to be 90.3 equals a current I don't know times 120 ohms of resistance. So 90.3 divided by 120, and I get 0.753 amps. So my current would be going through that way 0.753 amps, which means I have got 0.753 amps going there, and that's the answer to this question here. Now, I had 1.93 amps going this way, so how much goes this way? Well, whatever's left over goes that way, correct? So whatever goes that way is 1.93 minus that answer, right? And I get, I did that wrong. Hold on, 1.93 minus the, we just discovered 0.753 going the other way. So I get 1.18. So I have no idea where, there it is, okay. So going this way, I have 1.18 amps. All right, that doesn't help me much for a parallel system because what I really need there is voltage, right? So instead, what I'm going to do is I'm going to deal with it over here where I know what's happening there. How much is going through there? Well, all of it has to go through there, so all 1.18 amps is going there. And by the way, all should be up here, 1.18 amps are going there, right? So that's the case. I now know that R4 is 1.18 amps, R5 is 1.18 amps, and I'm actually only down to 2 questions, which is how does that 1.18 split between these two up here? That I don't yet know. But I can solve for some voltages, right? I can say, look, my thing has to lose 100 volts, right? So I imagine my electron coming out of the battery. It dumps some here. Gets here, gonna dump some here. Gonna dump some here. Gonna dump some here, and then go all the way back to the battery. So I know that I'm going to have, I have 100 volts. I'm going to lose 1.93 times 5 going through that first one. This one right here, right? I don't know where my pin is. Here it is. Right here, right? And then I'm going to lose 10 times how much goes through that first resistor, that R2 resistor, right? Plus, I'm going to lose 1.18 times the 30 going through this resistor right here on my way back home. And then on my way back home, I'm going to lose another 1.18 times 40. Love it. And so from this, I can actually solve what I2 must be, right? So I'm going to go ahead and do that. I've got 100 minus 193.5. That just is totally not the way to do that. Okay, so 100 minus 1.93 times 5 would be the way to do that. Plus or minus 1.18 times 30 plus 1.18 times 40. And I get that I used pluses when I should have used minuses. Yeah, you heard that, no doubt. Delete minus. There we go. Boom. And I have 7.75 left over, right? So solving this problem, I get 7.75 equals 10 times I2. So I2 must equal 0.775 amps. Now let's try the other one. Same drill. I've got 100 equals 1.93 times 5 plus, now this time I'm going to have 20 times I2 plus 1.18 times 30 plus 1.18 times 40. Again, what am I doing? I'm walking around. I'm starting, see if I find my pen first here. I'm starting here. I start with 100 volts, right? I lose 5 times 1.93 there because that's my current through there. I'm going to lose something here. I don't know what it is, but it's I times 20, right? Going this way, I'm going to lose 1.18 times 30. Going through this one, I'm going to lose another 1.18 times 30, and then I'm home to the battery, right? So I have to use all 100 volts before I get to there, so that's what I'm going to do. 7.75 equals, I've got 20 times I3. So then I do a little bit of mathage, 7.75 divided by 20, and I get 0.39 amps. Where's my pen? Can't find it. There's my pen. So I get I3 is equal to 0.39 amps. And so now I look at the whole thing and go, okay, so those two have to add up to what? 0.39 plus 0.775. That better add up to 1.18. And I get 1.17, which caused me a little bit of stress, feeling a little bit nervous about it, but that's a rounding error, so I can live with that. And then coming home, what does this ammeter read? Well, this ammeter is all the current coming through this wire. Well, that was 1.18, right? So 1.18 amps. Whoop. And then what does my voltmeter read? I go back into voltmeter. Voltmeter is going to be the voltage drop across here, correct? And we know that there the voltage is equal to 1.18 times 40. And so my voltage drop across that thing, what my voltage meter would read, what electrons would lose going across that voltmeter, although many would not go that way, hopefully, because it's supposed to be not changing my circuit. And I get 45.6 volts. And there I am. So that's how you do the uber complex, awful, horrible, worst problem I could possibly think of. Well, not worst problem I can think of, but the worst problem you could ever possibly see in this sort of a context of an algebraic AP class. So I'm going to pause it now. Try number 4.